explorers, and welcome to my office. I am so excited that you're here. As you can tell, I have a lot of cool things on my desk to share with you today. We'll meet here every time before we head out on our adventure to make sure that we're ready for our journey. We'll always want to make sure that we have two things with us. You'll need your passport every time, and you can get that at centeradventure.org. And then you'll always need to make sure that you have your explorer tools. Every explorer needs to make sure they pack their tools. Those tools are your imagination, your willingness to learn, and the ability to ask good questions. I know that all of you already have those things and you're ready for our adventure. Okay, boys and girls, as you can see, I have a lot of really cool things on our desk. And for our adventure today, you are going to be heading out to meet with two civil engineers. And one of the things that they design are dams. Now, I wonder if you can think of anything or anybody else that you might know that lives out in the wild that builds dams. You might be thinking about a beaver. And today, right here in my office, I'm going to build a dam for you like what a beaver would build out in the wild. Now, when you go meet with your engineers that you're going to meet with today, they're going to tell you the kind of dam that they design is not the same kind of dam that a beaver would build. You're going to learn about a different kind of dam, in fact, several different kinds of dams that engineers design. But today, let's look at a dam and what the purpose is of a dam before you head out on your adventure. What do you think? Okay, so in my container here, I already have some mud because every dam needs a foundation to it, right? So I already have some mud because a beaver would work really hard to get some mud together for the foundation of its dam. And then it would work even harder to bring some rocks or some bigger things over to lay on top of its foundation. So I brought some rocks today and I'm gonna mash those down and I'm gonna bury them into the mud. I'm gonna put them in there. Now, the purpose of a dam is to hold water in a specific location. And today you're going to learn about lots of different purposes of dams, like why you would want to hold water in specific locations. There's many reasons why you would want to do that. Okay, and now I have some sticks here because we all know that beavers love sticks and they would work really hard to bring a bunch of sticks over and layer the sticks around their dam. And then I have a jar of some other stuff, just some dirt and stuff that I'm gonna pour on here. If you've ever seen a dam that a beaver has built, it's got all kinds of stuff on it. Okay, what do you think? Think we're ready? So hopefully, I'm gonna pour the water right here and it is not gonna get over here. Are you ready to try? Let's see. Well, a little tiny bit is seeping through, but I think I did a pretty good job. How about you? All right, so when you head out for your adventure, and I'll show you in just a minute where you're going to be going, you're going to learn a lot about how dams are built and for what purposes. So let's head over to the map and check it out. All right, boys and girls, today you are going to be going to Engineering Concepts in Botetourt County. So we are right here in Roanoke, and you're going to be traveling up to Botetourt to meet with Bobby and Trey Wampler, who are engineers. And you're going to meet our friend Daniel there, so you'll get to spend some time with them and hear all about civil engineering. I hope you have a great time.
Hi Explorers, my name is Daniel James, and today we're going to have a fun adventure. You guys up for that?
Yeah.
That sounds fantastic. So today we are here in Botetourt County. We're at Engineering Concepts, and we're here with Trey and Bobby Wampler, and very excited to learn about engineering and about dams.
Sounds great.
So Bobby, the Explorers and I are kind of curious about what engineers actually are. What do engineers do?
Okay, so engineers, we primarily design things. So there's different types of engineers. There's mechanical engineers, there's electrical engineers, there's structural engineers. We are civil engineers.
Okay, so it's not just engines to engineer, there's a whole variety of things. And then what do civil engineers do?
Sure. So civil engineers, we typically do things that deal with nature, with land, with water.
Okay, so and you're building these things, or are you designing them? What part?
So we're just designing them. So some of the things you might be familiar with, like a road. So we would design the roadway. We wouldn't build it, but we would determine where it is. We would design things like dams.
And then what kind of skill sets are helpful in your job and the things that you do?
A lot of math. There's a lot of math, a lot of computers, a lot of computer programming.
Okay, and is that something you have to be good at math?
You have to be good at math to be an engineer.
And why is that?
Everything we do deals with numbers and designing and working with probabilities.
So we were going to talk a little bit about dams today too. What types of dams are out there?
Sure. So when we think about dams, dams are actually the dirt, the embankment. It can be that holds the water back. So when we think about dams, most of the time we're thinking about the water behind the dam. So that water can be used for recreational purposes. It can be used for flood protection. It can be used for improving water quality. It can even be used to generate power.
And I know dams used to be built a lot for agriculture, right? For
Yes.
irrigation. What are they used for now a lot of the times?
A lot of times deal with flood protection. So as we develop land, we take things like grass that the water kind of percolates into the ground, and we would pave over that. So now the water's running off the ground. So we have to capture that water so we don't flood downstream.
Okay, and then do dams like filter the water? Do they, like, what roles do they play?
Yeah, they do. They capture sediment, so the dirt that would run through the stream. So after a storm, you might see where a river that normally is blue, it turns brown. It's because it has dirt in it. So as the water were to enter a dam, an impoundment, that dirt would settle out to protect the downstream.
So is there an example of a dam nearby too that is one of these hydroelectric dams?
Yes, the Smith Mountain Lake Dam nearby, it's a hydroelectric dam. It also creates a large recreational facility for folks to use.
So that's something that the Explorers could actually go and visit and then potentially learn about how much electricity that gets off.
Yes.
That's cool. Okay, so Smith Mountain Lake is a place that the Explorers can go check out, use the lake too, but also see how that dam works. Is there somebody that you were mentioning a lot of, like the water tables and like how the water works too? Is there somebody that we could talk more about that with?
Yes, we could go talk to Trey.
Perfect. Thank you, Trey. I was gonna say, we got a lot of interesting information from Bobby, and he was talking a little bit about these predictions and knowing where water goes. So how does water play into these dams and other projects?
Yeah, so obviously when you're dealing with dams, you got to hold the water back. So it's important to know how much water you're going to be dealing with, where the water is coming from. And a lot of that we have to predict based on patterns in the area.
So when I watch the weather, right, and I try to see what they're predicting, they do a okay job, we'll call it that. How do you guys predict how much water is going to be going through dams?
Yeah, so we predict based off of the history in an area. So if you look at the history of an area, day to day, maybe the predictions are off, but typically over years and years and years, we have a good idea of what's going to happen. So we'll look at the history in an area. How often do you get a storm with this much water or a storm with that much water and things like that.
So when there's a day, let's say when there's just a ton of rainfall coming down and water's just going into all these places, what do the dams do? Are there like people there holding the levers to open it? How does it work?
Typically, a dam is going to be designed ahead of time to account for all these different flows that may come through. So you'll have different orifices, which an orifice is just a hole that can account for the water that would come on a certain day. You'll have spillways, which is kind of a path for the water to go down, and that may handle the water. So there's typically different things built into the dam to account for the different flows they might see.
So what are some of these methods that you guys use to make some of these predictions?
Yeah, so we actually use data that other engineers have looked at and then provided on a website that we can go to and look at the 2, 10, 100-year storm, which a 2, 10, 100-year storm, for example, you look at how likely is a storm going to happen in a 2-year span, or over the course of 10 years, or over the course of 100 years. And then we base our predictions off of those.
So a 100-year storm, if it doesn't come within 100 years, it's not late.
It just didn't happen.
Didn't
we
happen.
expected it to happen, but it didn't happen. So it's a
Gotcha.
prediction. It's not a guarantee. We don't read the future. We just try and guess.
So is it something that I wouldn't notice all the time? I would just be driving down the road and there's an embankment or a dam or something that's nearby, but that was intentionally designed.
Yes, there are dams everywhere that have been intentionally designed that we don't even notice.
Okay, and that's mostly just to make sure we want to know where the water is going so that it doesn't go into people's houses or...
Yes, that's usually dams are built around here to protect houses and protect people from floods.
There are examples of this nearby that we can go look at to learn more about it?
Yeah, we have dams right around here. I can show you.
I would love to see one. Let's go, explorers. Can you tell me a little bit about what this is and what's happening, why there's water over here? Just explain a little bit about what it is.
Sure. So what we can't see from here is on the other side of that, there's about a 17-acre lake. So what happens is, so what we have here, this is the water that will be coming into the lake from the stream, and it's just being discharged from the bottom of the lake to get the colder water, and it's coming down a staircase to get air in the water for the health of the stream and the fish and the aquatics. And then we have over here, what we're seeing the back of this concrete wall, that's if we have a large storm event that Trey was talking about, maybe a 100-year storm. We'll see that water start coming over all the way the entire length of that wall. Yeah, so the dam, we can actually consider this entire green, the mound of dirt, that's called the embankment. That's actually what holds the water back. And then what we have here is more of what we call the spillway, the emergency spillway, the primary spillway.
So
to
how
control
would you,
the storms.
That's a lot of dirt.
Yes.
So how would you calculate how much dirt you need to tell the builders?
We use math, we use computer programs. So again, Trey was talking about probability. So we would first determine what type of storm event we want to design the dam for. That would let us know how much water we have to hold back, which allows us to then calculate the amount of dirt needed to build this embankment.
So do they usually take lakes that already exist and rivers that already exist and turn them into dams? Or is it sometimes like they build the whole lake too?
This actually was built from the beginning. There was a stream that went through here, so we built the entire lake, including digging out the bottom. So that doesn't always happen, but water goes to the low point. So whatever's going downhill, that's where you would build a dam.
So all the fish and the birds and the different ecology that's up there too, that wasn't as robust as before.
That's correct.
Okay, so they allow them to come here too. And then when we're looking at this too, like, is that a path that I can skip on? What are those stones there for?
Those stones are there to dissipate the energy, to slow the water down. So when you see a big storm event, like a 100-year storm that causes flooding, when that water starts to come over top of that wall, there's a lot of energy. And we have to get that energy down, otherwise we have erosion downstream.
I got you.
So those are called stilling blocks that kind of slow the water down.
Stilling blocks, and so they just keep it from like rushing all at
Yes.
once. And so then it just kind of comes out. So it comes out at the pace that you guys hopefully want it to, so that it's safe for everybody further downstream.
Yes.
And is there a certain name too for like the watershed that we're in here in
This is the
Virginia?
Tinker Creek drainage basin that we are in currently.
How big is that?
This dam receives water from about 1,000 acres.
Okay.
So when we talked about Smith Mountain Lake, it got water from 1,000 square miles.
Okay, so different dams have to be able to anticipate where the water's all coming. And can you tell me a little bit too about what a water table is?
The water table is when the rain falls, it falls onto the ground. If it's on grass, it's able to go into the ground. If it were to fall on concrete, it just runs right off. So then eventually the water goes down into the ground and it stabilizes to a certain point. And wherever the water stabilizes at, that's called the water table.
Okay, so a lot of the buildings that we have and a lot of the areas that we've built up, that water doesn't go into the ground as much anymore, so we have to figure out where it goes to.
Yes.
And so we need dams to be able to put that water in the right place so that it's safe for everybody.
That's correct.
Well, this has been very exciting. I want to say thank you to you too, and to Trey as well, for having us out here and explaining a little bit more about dams and a little bit more about water and how that works. And explorers, we're gonna head back to the office.
Welcome back, explorers. Thank you so much for joining us on this adventure. I hope you had a great time learning all about dams. I had no idea that they're built for so many different reasons and that they're so popular. I bet while you're out and about now, you're going to be looking for dams in your area. Boys and girls, I hope you had a great time today. I know that I learned so much. Until next time, thanks for joining us. See you later.